Hi, Lillian. Okay, last lesson. This one I'm going to have you do all 5 self-checks, but it should be pretty quick. It's all about square roots and simplifying square roots, adding, subtracting, multiplying, dividing square roots. So the first self-check 12.1 is just asking you to simplify square roots. The way that I like to do this is with a factor tree. Let me just change the color of my pen. So when I have a square root, what I'm going to do is just draw kind of like 2 lines off of it and figure out 2 numbers, and they can be any 2 numbers that multiply by 54. So I'm going to pick 9 and 6. If you couldn't think of numbers that multiply to be these things, you can always divide by what you know, like divide by 2 or divide by 3 and continue to do that. So now I have 9 and 6. I'm going to break 9 and 6 down up again because I know that 9 is 3 and 3. And I know 6 is 3 and 2. And I could continue to go through that like that, but this is it. Like, I can't break 3 down smaller than 3. We want to get it to what it's called prime factors, and 3 is considered prime because there's nothing that I can divide it by. Same thing with 2, so I can't break this down any further. Once I get it to a point where I can't break it down any further, what I'm going to do is circle my pairs. So if I have a pair of something, I'm going to circle it. I have a pair of 3s right here. And what I circle pops outside of the square root. So my final answer would be 3 square root 3 times 2, or 3 square root 6. Now let me explain that. The pair of 3s that I circle kind of morphs into 1 3 and goes on the outside of the circle. So those pairs of 3s turned into this 3 right there. And then what I didn't circle stays on the inside of the square root, and I just multiply the 2 numbers. So that's why my final answer right here is 3 square root 6. Okay, so let's do this next example. 36, square root of 36. You can use a calculator in this. I have no problem with using a calculator, but anytime that your square roots don't end up being really pretty, you're going to have to kind of do some work by hand. Because if you put a square root, like square root 54 into your calculator, it's going to give you a really gross decimal. I don't want the decimal answer. I want the square root answer. So 36, I know, is 6 times 6. I'm just going to show you this. I could have stopped right here. I can stop right here because I have a pair of 6s, but I'm going to break it down into my prime factors. So I know 6 is 3 times 2, which means that this 6 is also 3 times 2. So I have a pair of 3s right here and a pair of 2s right here. So I have a pair of 2s, I'm going to morph it into 1 2. I have a pair of 3s, I'm going to morph it into 1 3. And then what's left on the inside? I didn't, like everything else I circled, so there's nothing left on the inside of my square root. But there is this 4 right here, which means that that is also on the outside of my square root, so I'm going to just tack a 4 on front. So now I have 4 times 3 times 2, which is 24, and that's my final answer. Okay, so the last 2 examples on here have variables in them. We're going to treat them the same, and then I'll show you how to deal with the variables. So I'm going to start with the 96, and I'm going to do 96 is 8 and 12. 8 is 4 and 2, and then 4 is 2 and 2, but I can't break up the other 2. 12 is 2 and 6 is 3 and 2. I'm going to circle my pair, so I have a pair of 2s right here and a pair of 2s right here. And that's it. Which means that I'm going to have 2 2s on the outside plus this 5 right here. So I'm going to also multiply by 5. And then what's left on the inside is these things. So 3 times 2, which is 6. And now let's talk about this. Well, actually, so 5 times 2 times 2 is 20. So I've got this 20 square root 6. But now I got to talk about this x to the 4th. So x to the 4th is the same thing as saying, oh, I've got 4 x's. So 1, 2, 3, 4. And I can actually do the same thing as what we did, is kind of like break it up and pair it off. So I've got 2 pairs of x's, which means that I can pull 2 x's to the outside of the square root, which means my final answer on this would be 20x squared square root 6. And there wouldn't be any x's left on the inside of the square root because I've circled all of my pairs of x's. Okay, now let's talk about example number 4. Once again, I'm going to start with the number on the inside. So 18 is 9 and 2, 9 is 3 and 3. I circle my pair of 3s, which means the 3 comes out, but the 2 stays in. So I'd have negative 2 that was already on the outside, times 3 from the pair, and then square root 2. So just for the numbers, I end up with negative 6 square root 2. And now I'm going to do the same thing with the x's, y's, and z's. So I have 3 x's, right? So I'm going to just do 3 x's right here. I circle one pair of x's, but then I have an x left on the inside. So I'm going to have negative 6x. That x is from the pair. And then the square root of 2x. The x that's on the inside is the one that was left out, the one that didn't get circled. Then let's do the y's. The y's have 8. So when it's a even number like this, you just divide it by 2. 8 divided by 2 is 4. So I can have 4 y's on the outside of my square root. So I can say y to the 4th right there. And then z is to the 9th. So I can have I can write out 9 z's and circle my pairs, but I'm going to tell you I'm going to have 1 z left over because it's an odd number, right? But how many pairs of z's do I have? I have 4. So my final answer would be negative 6x y to the 4th z to the 4th square root 2xz. All right. So that's how we do that. Now, the rest of these self-checks are like adding, subtracting, multiplying, stuff like that. But you're still going to have to use what you learned in 12.1 for a lot of these. So 12.2 is all about how to add and subtract square roots. In order to add and subtract square roots, you need to have the same thing on the inside of the square root. And so, for example, number 1 has 4 square root 5 plus 3 square root 5. Because they both have square root 5s on the inside, we can actually just add them together as is. And when we add them together, you leave the square root 5 and you just add the outside number. So 4 plus 3 is 7. So my final answer right here is 7 square root 5. Okay. But then if I look at example number 2, it's 2 square root 18 plus 2 square root 8, and 18 and 8 are not the same thing, which means I can't add them right now. Now that doesn't mean that I just stop and I'm done, but what it does mean is that I have to kind of change it so that they're both the same thing on the inside. So I'm going to do the factor tree for 18, which gives me 9 and 2, 3 and 3. 8 would give me 2 and 4, and 2 and 2. I circle my pair of 3's right there, which means it pops out. So I would have 2 times 3 on the outside, which would be 6 square root 2. So this whole thing right here changed to 6 square root 2 because I did this pair of 3's times this 2, which was already there. 3 times 2 is 6, and then this 2 right here got left on the inside. And then for the 2 square root 8, I have a pair of 2's right here. So I'm going to do this pair of 2's times this 2, which gives me 4, and then square root of 2 because this 2 is left out. So again, this is just a different way to write it. It's the same number, it's just a different way to write it. So now I have the same thing inside the square roots. I can add them together. So I do 6 plus 4, which gives me 10, and then it would be root 2. So I don't add the things inside the roots together. I leave the root as is, like it's a square root of 2. I leave it a square root of 2, but I just add the outsides. All right, let's look at number 3. Once again, you have different things on the insides of your square roots, so you have to get them to be the same. I'm going to do the factor tree for 12, which gives me 4 and 3, 2 and 2. I circle my pair of 2's. That pops out, so now I'm going to have negative 3 from this outside times the pair of 2's, which gives me negative 6 square root 3, because this 3 was left out. It didn't get circled. Now 3 square root 3, I can't factor tree 3. It's a prime number, so I just leave it as plus 3 root 3. And this is a really good sign because I have 2 root 3's, which means, okay, great, like I'm on the right track. I should be able to add something at least, or simplify a little bit. And then this 27 is 9 times 3, and we know 9 is 3 times 3. I circle my pair of 3's. This 3 gets multiplied by the negative 3 on the outside, which gives me negative 9. Then square root 3 from this 3 right here. Now I have all root 3's, which means I can add the outsides. So I'm going to do negative 6 plus 3, which is negative 3, plus a negative 9, or minus 9, which gives me negative 12, and then root 3. And this is my final answer. Sometimes you might have it that like they don't all end up with the same root, and that's okay, just as long as you are able to at least simplify one of the portion, like at least 2 of them will come together. Okay, so this one, again, we've got to get the same root. So I'm going to start with this 27. We know it's 9 times 3, and 9 is 3 times 3. We circle this pair of 3's, which gets multiplied by this 2. So you'd get 6 root 3, because that 3 didn't get circled, minus this 3 root 6 cannot be simplified. Even though 6 can break down to 3 and 2, there's no pairs, so it just is left square root 6. Let's break down the 12. You would have 6 and 2, and then 3 and 2. You have a pair of 2's right here, so that gets multiplied by the negative 2 that's on the outside. So I'd get negative 4 root 3, because that 3 got left out, it didn't get circled. 54 is 6 times 9. 6 is 3 and 2. 9 is 3 and 3. I've got a pair of 3's right here, which gets multiplied by this negative 2, so I'd get negative 6 on the outside. Then on the inside, I'd have 3 and 2, so we multiply those two things, which gives me 6. So this is a good example of one where, like, it's not all going to come into one square root, but you can combine some. So, like, we're going to add these two together because they both have root 6's, and then we're going to add these two together because they both have root 3's. I'm going to start with my root 3's. So I have 6 root 3 minus 4 root 3. 6 minus 4 is 2, so I get 2 root 3. And then for my root 6's, I have a negative 3 square root 6 minus 6 square root 6, which would give me negative 9 root 6. And this is my final answer. All right. Now let's talk about 12.3. So 12.3 is multiplying square roots. So when we multiply square roots, we just multiply what's outside with what's outside, what's inside with what's inside, and then we simplify our answer. So for example number 1, 4 square root 5 times square root 12. We only have one thing on the outside, which is 4, so I just leave that 4 on the outside. And then the square root on the inside would be 5 times 12, which is 60. All right, so that's a really pretty answer, but we can simplify that by doing the factor tree. So 6 and 10, 3 and 2, 2 and 5. I have a pair of 2's right there, which means it's going to be multiplied by this 4 right here. So I end up with 8 root, and then the things that didn't get circled were the 3 and the 5, so it'd be 3 times 5, which is 15. My final answer is 8 root 15. Okay, for the second example, we're going to do the same thing. So the only thing on the outside right now is this 3, so we leave the 3 on the outside. Then on the inside, we're going to do 20 times 15, which is 300. And then x times x to the 4th, which gives me x to the 5th. And now we just simplify. The 300 can be 3 and 100. Then I can do 10 and 10. I could split the 10's up, but as soon as I have a pair, I can circle that pair. So I have a pair of 10's, which means it pulls to the outside and multiplies by that 3. So I end up with 30 on the outside. And then 3 on the inside because that didn't get circled. Now we're going to deal with this x to the 5th. So how many pairs of x's do I have? Well, I'd have 2 pairs of x's, right? So I have 5 x's. So 1 pair, 2 pair, and then 1 left over. So it would end up being 30x squared because I have 2 pairs of x's, square root 3x because that 1x got left out. All right. And then on number 3, we're going to use the distributive property. So we're going to multiply the square root 15 by 2. Because you have the 2 that's not inside the square root and then the 15 that is inside the square root, they kind of just get mashed together by doing 2 square root 15. Plus square root 15 times square root 5. We're going to do 15 times 5, which gives me 75. So it's root 75. This 2 square root 15 that's in front can't be simplified. Even though 15 is 5 times 3, those are both prime numbers, so there's nothing to circle, there's no pairs. So we leave the 2 square root 15, but the 75 we can simplify. We know that's 15 times 5. We know the 15 is 5 times 3. So we have a pair of 5's, which means I'm going to pull it out to be 5 root, and then the thing that got left out or didn't circle was 3. So my final answer is 2 root 15 plus 5 root 3. Okay. And then this last example is unfortunately the hardest, but that's just because we have to FOIL. So I'm going to start right here. Negative 1 times negative 4 gives me 4. Then negative 1 times negative square root 3x would give me a positive 1 square root 3x. Then we do these ones. So 5 square root 3x times negative 4. We multiply the 5 and the negative 4, gives me negative 20 root 3x. And then 5 root 3x times negative root 3x would give me negative 5 root 3x squared, because it's just like another 3x, an extra 3x. Do you know a square root and a squared cancel each other out? And so really I have 4 plus 1 root 3x minus 20 root 3x minus 5 times 3x, which gives me negative 15x. Because I just multiply this negative 5 times the 3x, because the square root and the squared cancel each other out. Now we just combine like terms. The only like terms on here are these two because they both have root 3x's. So my final answer would be 4 minus 19, because 1 minus 20 is negative 19, root 3x minus 15x. And there we have it, my final answer. All right. The next self-check is how to divide square roots. So the big rule on here is that we do not like square roots on the bottom of fractions. It's some rule that some old dude made up, but now we all follow it. So if you have a square root on the bottom, we have to get rid of it. And the way that we're going to get rid of it is by multiplying by what's called the conjugate. So the conjugate just means that we take the square root portion and make it negative. So I'm going to multiply by negative 5 root 2 on top and on bottom, because what I do to the top, I have to do to the bottom. This isn't changing the value of the fraction, it's just changing the way that it looks. So in order to do this, you need to multiply both the top and the bottom by the same thing. So on the top of this, we're going to have 4 times negative 5 root 2, which gives me negative 20 root 2 on the top. And then on the bottom, we'd have 5 times negative 5 gives me negative 25. Root 2 times root 2 gives me root 4, right? Because we just multiply what's on the inside. Well, we know the square root of 4 is 2, so I can scratch that out and make that times 2. So I end up with negative 20 root 2 over negative 25 times 2, which gives me negative 50. And then we can simplify that just because we can take the negatives out. A negative divided by a negative is positive. And then we can also simplify the 20 and the 50 as long as they're not inside the square root and they can simplify each other, that's good to go. So they're both divisible by 10, which means my final answer is 2 root 2 over 5. I just divided the 20 and the 50 by 10. Okay. And even though that looks super similar to what you started with, it's different because the root now is on top rather than on bottom, so we like that a lot more. Okay, so the second example, I'm going to multiply the top and the bottom by negative 3 root 15. We just changed the sign. There's a reason why we changed the sign, and I will show you that in the last example. So just make sure that you always change the sign on the root portion. So on the top, when we multiply, we're going to end up with 2 times negative 3 gives me negative 6 root 5 times 15 is 75. Then on the bottom, we have 3 times negative 3, which gives me negative 9. Root 15 times 15 is 225. We know that the square root of 225, you can plug that into your calculator, but it's 15. So I can change that to a 15. And that also shows me that I do it right, because the square root should disappear from the bottom. And so now we have negative 6 root 75 over negative 9 times 15, which is negative 135. Okay. Now, we can simplify the square root of 75. I'm going to cheat and go back up here and look at this guy right here. The square root of 75 was 5 square root 3. So if I use that and change the square root of 75 times 5 is 5 square root 3, then I get negative 6 times 5, which is negative 30 square root 3 over negative 135. We can simplify the 30 and the 135 by first taking out the negatives, and then we can divide both of those by 3, I believe. Yeah, in fact, we can divide both of those by 15. So we end up with 2 root 3 because 30 divided by 15 is 2. And then over 9 because 135 divided by 15 is 9. So that's my final answer. Okay. Almost there. So again, on example number 3, I'm going to multiply by negative 2 root 5 on top and on bottom because what I do to the top, I also have to do to the bottom. On this top, I have to distribute this to the 2 and to the root 3. So I'm going to end up with negative 4 root 5 plus negative 2 root 15. So I really don't need that plus there. I can just say minus 2 root 15. Over 2 times negative 2 gives me negative 4. And then root 5 times root 5 is root 25. But we know that the square root of 25 is 5, so I'm going to just change that to a 5. So then I end up with negative 4 root 5 minus 2 root 15 over negative 20. Once again, we can simplify the outsides by taking out the negatives. So I'm going to just cross those out and then make this a plus. And then I can divide everything by 2. So I'd end up with 2 root 5, all the stuff on the outside by 2, plus 1 root 15, or I can just say root 15 over 10. And this would be my final answer. Okay, last one. So this one, you have 2 chunks on the bottom. And when you have that, this is where it's really important to make sure you switch the sign on the root part. So I'm going to multiply both the top and the bottom by 5 plus root 5. I'm changing it, I'm changing the middle sign, or I'm changing the sign on the root portion. And you have to do that or else the bottoms won't cancel out, right? So we're going to have to FOIL both the top and the bottom. When I FOIL the top, I'm going to end up with negative 15 minus 3 root 5 plus 20 root 2 plus 4 root 10 over, now I'm going to FOIL the bottom, 25 plus 5 root 5 minus 5 root 5 minus root 25. So the top can't be simplified, we just leave it like that. On the bottom though, if you look, these middle 2 can cancel each other out because one's positive 5 root 5 and the other is negative 5 root 5. And so they cancel each other out. And then we know that the square root of 25 is 5, so I can change that to just a 5. So the bottom now is 25 minus 5, which is just 20. So my final answer is negative 15 minus 3 root 5 plus 20 root 2 plus 4 root 10 all over 20. And this, you can't simplify anything on the outside because some of them are odd, some of them are even. They won't divide by anything, by like a common denominator. So this is my final answer. Okay, and the last self-check that I'm going to have you do in lesson 12, or the last self-check in lesson 12, is how to solve equations with square roots. So number 1, I screwed up the example sheet. It should look like what I have on my paper, or it should look like what I have down in this video. The square root of x is equal to 3. And that's why I put a little star next to it. On your paper, it says square root of 3 is equal to x. I just switched it. So the goal here is to get x by itself, or to solve for x, which means I need to get rid of the square root. The opposite of a square root is squaring. So what I'm going to do is square both sides. And when I square the square root and the square cancel each other out, which means I'm just left with x over here. And then it's 3 squared on the other side, which is 9. So my final answer is x is equal to 9. All right. And then the second example, well, the first example is super easy, right? The second example is a little bit harder. When you have extra numbers and stuff, the first thing you want to do is get the square root portion by itself. So what I'm going to do is add 6 to both sides because the 6 isn't inside the square root. So I get x minus 8 is equal to negative 4 plus 6 gives me 2. Something to be aware of, you can't have a square root that's equal to a negative number. It just doesn't work. So if you end up with something with a negative that's equal to a negative number, it's no solution automatically. Okay, and then, so now that I have the square root by itself on one side, what I'm going to do now is square both sides. And then the square root and the square cancel each other out. So I'm just left with x minus 8 right here. And then 2 squared gives me 4. And now I can solve it like a normal equation by adding 8 to each side. So I end up with x is equal to 12. That's my answer. Okay, the third example, you have a square root on both sides, which actually makes it super easy because now I can just square both sides and they cancel out the square roots. And you're just left with what was inside. And now I'm just going to solve that for x. So to solve it for x, I'm going to get the x's on the same side first. The x's cancel out over here. I get 2x minus 6 is equal to 20. Now I want to get the x by itself. So I'm going to add 6 to both sides. So I get 2x, because these x's cancel out, is equal to 26. Then I'm going to divide each side by 2 to get rid of the 2 next to the x. I get x is equal to 13. And that's my answer. All right. One more example. So once again, we want to square both sides. But when you have 2 chunks like this on one side, you have to put them in parentheses and then square that. So this square root cancels out. We just are left with x plus 2 right here. But on the other side, we have x minus 4 squared, which you can't just say like x squared minus 4 squared. You actually have to FOIL it. Because x minus 4 squared is the same thing as saying x minus 4 times x minus 4. So then I'm going to FOIL and get x squared minus 4x minus 4x plus 16 was equal to x plus 2. Combine my two like terms, I get x squared minus 8x plus 16 is equal to x plus 2. Now, because I have an x squared, what I'm going to do is shove everything over to the left side. So I'm going to subtract x from each side. X squared minus 9x plus 16 is equal to 2, and then subtract 2. X squared minus 9x plus 14 is equal to 0. Now that I have it like this, I can either use the quadratic formula or I can factor. I'm going to choose to factor using the box method. So x squared goes up here, 14 goes down here. My goal is to multiply to be 14 and add to be negative 9, which would be 7 and 2, but both of them are negative. So negative 7 times negative 2 would give me a positive 14. Negative 7 plus negative 2 gives me a negative 9. So I'm going to put negative 7x in one box, negative 2x in another box. What do the bottom 2 boxes have in common? A negative 2. Top 2 boxes have an x in common. Left 2 boxes have an x in common. Right 2 boxes have a negative 7 in common. So my factors are x minus 2, x minus 7 equals 0. When I have factors like this, I can set each chunk equal to 0. So I can say x minus 2 is equal to 0, x minus 7 is equal to 0. Solve both of those. I get x is equal to 2 and x is equal to 7. And both of those are answers in this case. And this is how we solve problems with square roots. Okay, I went really fast on that one. Again, email me if you have any questions at all, and good luck.